Hi everyone, welcome to part 1 of note section 3.1, which is covering the beginning of trigonometry, and we're going to discuss the tangent ratio. So if you're watching this today, this is part 1. These notes are divided into 3 parts, part 1, 2, and 3. So this is the first part here where we're going to simply discuss what the tangent ratio is and how to label a triangle, a right triangle. So let's begin. Right triangles, there are some basic terms and symbols that we need to know. The first of which is that a right triangle, of course, is a triangle that has an angle of 90 degrees. And on this particular triangle, I see that my 90-degree angle is right here. Okay, and I use a little corner of a box to designate a right triangle of 90 degrees. With triangles, we generally label the points or the vertices of the triangles with capital letters. So for example, A, B, and C. And it's more common to label the sides with lowercase letters like A, B, and C. Although we don't always have to do this. Sometimes it is easier to describe the sides as, for example, this side here is the side AB. Okay, it's the side that is formed between the angle A and the angle B of the triangle, or the point A and the point B of the triangle. Acute angles are angles that are less than 90 degrees. So in a right triangle, both angle C and angle A are acute angles. They are less than 90 degrees. Okay, and an obtuse angle is an angle that is greater than 90 degrees. We should write that over here. An obtuse angle is greater than 90 degrees. So it might look something like this. If this is a 90-degree angle right here, okay, an obtuse angle would be, for example, the angle formed here. Okay, an obtuse angle is greater than 90 degrees. We use Greek symbols from the Greek alphabet to label the angles in a right triangle or in any triangle. Really commonly used letters are alpha, beta, which looks like a capital B with sort of a longer tail, and theta. And theta looks like a 0 with a little loop through the top. That's theta. And these are really commonly used to show the angles on a triangle. So for example, I'll give you an example here. We might call, instead of saying angle A, we might say this is alpha. Okay, and angle C, we might decide to call angle C theta. Okay, you're going to see a lot of the symbol theta in our notes in this section as well as in the textbook. The hypotenuse is always the side that's opposite or across from the right angle. So whenever I look at a right angled triangle, I find my right angle and I go directly across from that right angle, and there is my hypotenuse. Okay, I can always label the hypotenuse for any right angled triangle. It's always the side across from the right angle. Notice that we're going to use this symbol here that looks a little bit like a slanted L to mean angle. Okay, so for example, I could talk about angle A. I would write angle A. Okay, or angle C. Okay, for example. And when you see that little symbol, that symbol means angle. We need to know how to label the other sides of a right angle triangle. So if I give you this triangle here, and I tell you that this is your right angle right here, so we should put that in. Okay, there's my right angle worth 90 degrees. The first thing I can always do is label the hypotenuse. I know the hypotenuse is the side that is directly across from the right angle, and I'm just going to use HYP here to abbreviate hypotenuse. So there's my hypotenuse. The other two sides have names as well. When we go to label the other sides of a triangle, we have to label them in reference to one of the angles in the triangle. And it's going to be one of the other two angles that is not 90 degrees. So let's say, for example, okay, that we're interested in this angle right here. I'm going to say this is the angle that I'm interested in. So whenever we're doing this, whenever we're labeling the sides of a triangle, we always are going to label them relative to some angle that's being considered. So for this one, theta is the angle of interest, or the angle that we are considering. So if this is the angle that we're considering, the two sides that we will label will be the opposite side and the adjacent side. And the opposite side is very easy to label. Just like the hypotenuse was the side across from the right angle, the opposite side is the angle directly across or opposite the angle that we're considering. So this side right over here is going to be our opposite side. So here is my opposite side. Okay, so the opposite side is the side opposite or directly across from the angle that you're considering. The other side is your leftover side. Okay, this side right here is the only side I haven't labeled yet, and it's my adjacent side. Adjacent side. And sometimes we use ADJ to abbreviate adjacent side, just like OPP for opposite. Okay, the adjacent side is the side that's formed between the two arms. So the leftover arm that is not the opposite, okay, and the hypotenuse. So it is formed by the arms of the acute angle, okay, and not the hypotenuse. So in other words, it is formed by the adjacent is, let me see if I can say that a little bit more correctly. The adjacent is the side that forms one of the arms, pardon me, with the acute angle. So here's my acute angle, angle theta. So it forms the other arm that is not the hypotenuse. Okay. Excellent. This is the first step for every single type of question that we will deal with in trigonometry. The first step is to label the sides of your triangle. Let's do another example. Let's label sides of this triangle. Here's what I'm going to give you. I want to tell you that this is triangle ABC, and it looks like this. This is A, this is B, and this is point C. Here's your right triangle, right here. So angle B is 90 degrees. And let A be the angle that we are considering. So let's let angle A let's let angle A be the angle that we're considering, and we're going to label this triangle relative to angle A. So the first thing I'm going to do is I'm going to label my hypotenuse. Remember, there are three sides: hypotenuse, opposite, and adjacent. Let's label our hypotenuse first. Our hypotenuse is always across from the right angle, so there's my hypotenuse. The opposite side of this triangle will be the side opposite from the angle that we're considering. So it is going to be right over here. There's my opposite. So B to C is my opposite. The leftover side, okay, or the side that forms the other arm from the acute angle, right here, okay, that's not the hypotenuse, is my adjacent side. A really easy way to remember your adjacent side is it's going to be the side that you haven't labeled yet. If you always start with your hypotenuse and your opposite, which are very easy to label, the leftover side is your adjacent. There we go. So we've labeled our triangle, okay, correctly for all three sides. In trigonometry, we're usually trying to find either an unknown angle or an unknown side length. And we use trigonomic ratios to help us figure these unknowns out. There are three trigonomic ratios that we are going to discuss in this section, and they're called the primary trig ratios, and they are sine, cos, and tangent ratios. And we use a little saying here, and I'd like you to remember this saying. This is a memory trick to help you remember each one of these ratios. Now, before I show you the memory trick, I just want to tell you this is in your data booklet. All three ratios are in your data booklet, and if you have a moment to have a look at your green data booklet right now, I'm just going to pull it up right down here. Okay, here's our data booklet right here. If you have a look right on page 1 of your data booklet, right by the Pythagorean theorem, we've used this formula already in this course. Okay, right above it, you have the 3 trig ratios right here. Okay, so sine, okay, is equal to the opposite side over the hypotenuse. The cos of an angle is equal to the adjacent side over the hypotenuse, and the tangent of an angle is equal to the opposite side over the adjacent side. And so from this, we come up with our little saying SOHCAHTOA. And if you can remember SOHCAHTOA, which is SO, S-O-H, C-A-H-T-O-A. This is just a little way to remember these, okay? If you can remember this saying, you don't even need to use your data booklet, although you do have your data booklet to help you. The SO tells you that the sine of an angle is equal to the opposite over the hypotenuse. The cosine of an angle is equal to the A adjacent over the hypotenuse. And T in TOA stands for tangent. The tangent of an angle is equal to the opposite, O, over the adjacent. Okay, so it's just a memory trick. But of course you can use your data booklet as well. Let's go back to our notes here. Okay, so really quickly then, let me just show you what each of these means. Okay, so the sine of some angle, let's call it theta. The sine of the angle is equal to the opposite side. So once you label your triangle relative to your angle, you're going to take the opposite side and divide it by the hypotenuse. And that's going to give us the sine of the angle. CAH, ka, stands for cosine of an angle is equal to the A adjacent over the hypotenuse. So this is just a way for us to remember these. And today this is the one we're going to deal with, okay, the tangent of an angle. So the tangent ratio of an angle, let's call that angle theta, is equal to the opposite side over the adjacent side. And I'll use SOHCAHTOA over and over again in this course, so you'll remember it. Let's have a look at how to solve then for the tangent ratio. Let's do a real example. I have a triangle here, and I am going to label it. First of all, tan is a short form for tangent. This is just a short way of writing tangent ratio. Okay, so the tan of angle A, let's label this triangle for a moment. Let's call this triangle ABC. A, B, and C is our right angle. Okay, if angle A is an angle that we're interested in, well, there's my angle A right there. I could label this triangle relative to angle A. The first thing I'm going to do is label my hypotenuse. That's right across from my right angle. Then I can label my opposite side, which is right across from my angle that I'm interested in. So the side across from angle A is my opposite. And finally, my leftover is the adjacent side right here. Okay, so there's my adjacent. So I've labeled my triangle. If I had numbers for this triangle, I could plug them in. I don't, so I'm just for now going to write the formula for tangent of A. So the tangent ratio of A is equal to the opposite side divided by the adjacent side. Okay, SOHCAHTOA. TOA helps us remind ourselves that tangent is equal to the opposite over the adjacent side. What this means, the tangent of A, this simply means the tangent ratio of the angle A. Okay, if we put in a measurement for the opposite side, let's say the opposite side was equal to 5 and adjacent was equal to 3, we would plug 5 and 3 in, and we're actually going to get a number here. Okay, it's going to be a number or a decimal place, number, a decimal. And so what we have then is the tangent of A is equal to some number. And that number is simply this ratio. Okay, this is just a ratio. Some number over another number. What I'm not solving for right now, if I were to plug numbers in, is I'm not solving for the angle A. The tangent of A is a number. Okay, it's not the angle A. If I want to find the angle A, which I will do later on, I have to do something else to this. Okay, when I do get this number, when I plug my numbers in and I come out with this number at the end, this is not the angle A. Okay, we want to be really clear. This is simply the tangent ratio of the angle A. It's just a number that we get when we take the opposite and divide it by the adjacent. But this number that we get will allow us later on to figure out what that angle A is. Okay, let's do an example with some numbers. So on your notes here, you have a couple of triangles where they want you to solve for the tangent of some angle. Let's do the first one. We've got angle Q. Okay, well, here's angle Q right here. So there's Q, and notice that it's asking me to find for the tangent of Q. So Q is the angle that I'm interested in, and that's going to be important. That's going to help me label my triangle. All right, so let's label our triangle. Here's my right angle right here. My hypotenuse is going to be directly across from that. My opposite side is the side opposite from the angle that I'm interested in. So if I'm interested in angle Q, my opposite side is right over here, and it's equal to 8. The leftover side of this triangle is down here from R to Q, and it has a value of 10. So maybe 10 centimeters, 10 millimeters. To find the tan of Q, I'm going to use the tangent ratio. And the tangent ratio of an angle is equal to the opposite over the adjacent. Okay, so now I've already said that my opposite was equal to 8. Here's my opposite. So this is going to be equal to, I'm just going to plug in the values that I have for my triangle. So 8 is the length of the opposite side, and 10 is the length of the adjacent side. So I've written my tangent of Q as a ratio, 8 over 10. Let's go a step further and actually divide 8 by 10 and write this as a decimal. Okay, 8 divided by 10 is 0.8. And that is my answer. Notice that both of these are correct. It's fine to say the tangent of Q is equal to 8 over 10. It's even better to say the tangent of Q is equal to 0.8. Okay, so there's my answer. The tangent of the angle Q is equal to 0.8. Let's try the next one. Let's find the tangent of A. Again, find angle A right away. Well, there's A. Okay, there's the point A. So angle A is going to be the angle that's made right at this point. Okay, and I can label, immediately I could label my opposite side. It's going to be the side across from A, which is 16 over here. I can also label my hypotenuse right away because I see there is my 90-degree angle. So my hypotenuse is always right across from that 90-degree angle. And the leftover side is going to be the adjacent side, right over here, and it's equal to 7. So the tan of A, use your ratio. The tan of A is equal to the opposite over the adjacent side. And I have some values now. 16 is the length of my opposite side, and 7 is the length of my adjacent side. So I can do the math. 16 divided by 7 in my calculator, or in my head, a little bit greater than 2. It's going to be 2.3. And my answer then, if I state it down below here, the tangent of A is equal to 2.3. Excellent. Finally, one more to go. What if I'm given the tangent ratio and I have to draw myself a triangle? So here's our question. It says, draw a triangle EFG if F is the right angle. So this is my 90-degree angle. So angle F is equal to 90 degrees. And let's say that the ratio, the tan of E, is equal to 7/9. Okay, I'm going to give you this information. Let's draw ourselves a right triangle. Okay, I'll put my right angle right here. And right away I know that if this is the triangle EFG, that's my angle F. So I'm going to put an F at the point where the two arms meet at 90 degrees. And we can label this G and this E. It really doesn't matter. Okay. Now, I know that the tan of E is equal to 7/9, and I also know that the tangent, remember your SOHCAHTOA, or use your data booklet, I know that the tangent is always written as a ratio, opposite over adjacent, which tells me that if the ratio is 7/9, the opposite side is equal to 7, and the adjacent side has a length or is equal to 9. So we could go ahead and label our triangle. Okay, we're looking at the tan of E. So E is the angle that we're interested in. So here's our angle that we're interested in. I'm going to label my opposite side across from angle E. And I know that the opposite side is equal to 7. I can also immediately label my hypotenuse right here, although I don't know the value of my hypotenuse. Okay, my adjacent side is going to be the leftover side, which is right here. And I know that the adjacent side is equal to 9. Okay, so I've labeled as much information as I can. By the way, if you wanted to find out the length of your hypotenuse here, you could use Pythagorean theorem. A squared plus b squared is equal to the hypotenuse squared. So we could solve it if we wanted to. 7 squared plus 9 squared, okay, is equal to c squared. I'm not going to for now because for the moment, you know how to do that, and what I really want to talk about is writing these tangent ratios. Okay, excellent. So up to now, we've discussed how to label a triangle for each of the three sides, hypotenuse, adjacent, and opposite. And we've looked at how to write a tangent ratio. Okay, so I'm going to get you to, at this point, stop and carry on to part 2, where we will calculate some tangent ratios.